Hello all, welcome to the new video of signals and systems. In this video, we'll see what is frequency modulation. That is the theory part, and we will generate a frequency modulated wave, that is through simulation at the end of the video. So I shall be giving you the MATLAB code to generate frequency modulated wave so that you'll get a brief overview about how this FM works. Okay. So before that, we'll see what is frequency modulation, that is the definition. So the definition states that changing the frequency of the carrier according to the message signal is called frequency modulation. So this is the definition. So what we do in frequency modulation, we change the frequency of the carrier, which is of higher frequency, according to the message signal, which is of lower frequency. So this is simple technique is called as frequency modulation. We are all aware about what is amplitude modulation. So it has also a definition which states that in amplitude modulation what we do, the amplitude of the carrier is varied in accordance to the message signal. So this is the amplitude modulated wave. As you can see, the amplitude of this carrier wave is varied according to the message signal m of t. So in similar fashion, we can expect our FM wave to be in this fashion. Say y is equal to, since we are not touching the amplitude of the carrier, it will remain same as the carrier wave of the FM. So amplitude of the frequency modulated wave is same as amplitude of a carrier wave or signal. So the FM wave will have same amplitude as carrier. However, this part cos 2 pi fct, so this fc will be varied in accordance with message signal. So there will be something called as phi will be added. So this is a FM wave. Okay. So now what we'll do, we'll derive the FM wave so that we get a picture of how it is generated. Okay. So as you can see here, this is our message signal m of t. So it is of low frequency. This is low frequency signal. And this is our carrier c of t, carrier signal. So this has amplitude say AC. So what can we expect in our FM wave? So what we can expect is, we can expect our frequency modulated signal to have the same amplitude AC, however different carrier with different frequency, because the frequency of the carrier will be varied in accordance with the message signal. So let me draw a rough diagram of this FM wave. As you can see, this is the amplitude, or this is a message signal. This is our carrier. The frequency of the carrier is varied in accordance with the message signal. So the rough, it will roughly look like this. Here and here, and then it may look like this. So as you can see, the frequency is different from this part to this part, say f1, and here it is f2, because this is the message is different here in this part, negative part. So the frequency is varied accordingly. So this is our FM wave, that is frequency modulated wave. So this has same amplitude as this carrier wave. However, frequency is not same as this carrier, because since we have varied the frequency, there is information in it. Otherwise, there is no information in this carrier. This has no information at all. So this is the main point of modulation actually, is because there is no point in sending only carrier signal, because it has no message. So what we do, we change the properties of this carrier signal in accordance with the message signal. If we vary the amplitude of the carrier, then it is called amplitude modulation. If we vary the carrier of the signal, if we vary the frequency of the carrier in accordance with the message signal, it is called as frequency modulation. So this is how the FM wave looks like. So let me go straight to the equations. Let me derive one equation of this FM wave. Let us derive this equation now. So we have two signals now. One is message signal, M of t, and then we have carrier signal, AC cos 2 pi fct. So this is a message signal, and then there is a carrier signal, and then we generate a FM signal whose amplitude will be same as this, the frequency will be different. So we are not aware about the equation, but we know for sure that the frequency of this signal depends on this message signal. So what we can write? We can write the instantaneous frequency of FM, that is Fi of t. That will be Fc plus Kf into M of t. Okay, and for single tone modulation, our M of t will be of single frequency, say Am cos 2 pi fmt. This is single frequency. So our instantaneous frequency of FM, that is at any point t, the frequency of this FM signal will depend on M of t, that is message signal. So if for single tone modulation, what happens? M of t is Am cos 2 pi fmt. So we'll write it here, Fc plus Kf Am cos 2 pi fmt. So this is for single tone modulation. For single tone modulation, the instantaneous frequency of FM wave is this. The Fi of t is Fc plus Kf into Am cos 2 pi fmt, where Kf is frequency sensitivity. This is frequency sensitivity factor of what is that? Frequency modulator. Okay. So we have for single tone modulation, Fi of t is Fc plus Kf Am cos 2 pi fmt. So the maximum value of cos 2 pi fmt is 1. So that time our Fit will be Fc plus Kf into Am, and minimum value of this cos 2 pi fmt is minus 1. So this is max, and then Fit of min will be Fc minus Kf into Am. So this is 1 and this is 2. So delta f will be, that is this change, be kf into am. Okay, that is, it will be plus kf am if it is maximum, and it is minus kf into am if it is minimum. However, this is the change in frequency. So this is called as frequency deviation of FM signal. So let's move on. This is frequency deviation, which is an important parameter of any FM signal. Since now we are only dealing with single tone modulation. So now let's see the general equation of frequency modulated wave. So for that, let's define our signal S of t, that is FM wave is equal to AC cos theta of t. Let it be FM wave, where theta of t is 2 pi and then Fi into t, where Fi is instantaneous frequency of FM signal, which we just saw in the last part. So let's differentiate this theta of t. So d theta of t upon dt is equal to 2 pi Fi. Where, and then if you want to get theta, we need to integrate over both sides. And then it will come to 2 pi into 0 to t Fi dt. This is depends on time, Fi of t into dt. However, we know that Fi of t is equal to Fc plus kf into m of t. So if we substitute this value here, we'll get the value of theta of t. So this is the theta of t equation, and we are also aware of the value of Fi of t. We'll substitute that in this equation. So then what we'll get? We'll get 2 pi into 0 to t Fit of t is Fc plus kf into m of t, whole is dt. So if we expand that, we get 2 pi Fc into t plus 2 pi into kf 0 to t m of t into dt. Earlier we had defined that S of tb FM wave, whose equation, general equation is AC cos theta of t. So our S of t will now become, will substitute this theta of t in this equation. You can see substitute here. So then our frequency modulated wave S of t will be S of t AC cos, this will be 2 pi fct plus 2 pi kf 0 to t m of t dt. So this is our frequency modulated signal. So we have derived the equation for frequency modulated wave, and if we need the equation of FM wave for single tone modulation, we have to substitute m of t is equal to am cos 2 pi fm t. Okay, this is the general equation of FM wave. So Since this video exceeded the number of minutes which I had expected, in the next part I will derive the equation of FM wave for singleton modulation, and then we shall see the how to generate FM wave through simulation, that is through MATLAB. Okay, we'll generate one FM wave. You can practice it via the code and all. So that's all for this video. Thanks for watching. Please watch the part 2 video by clicking the part 2 link. Thank you.